Okay, let's look at some of these problems here, Eric. We got 6 problems. I'm going to work them here on Notability, and we'll just save them to a file, and I'll upload it to YouTube. So let's look at this first problem where we're graphing, and we're going to do a piecewise function, which means we're going to have a different graph or one graph, but we're going to comprise it of 3 different pieces because in this case, we have 3 different rules that we're going to look at here. So I'm gonna kind of move this off to the side, and then I'm gonna because I copied we copied the rule set over here, and it's gonna give me some more space. So we're just gonna kind of move this over to the side here. So now I'm gonna draw a graph, and then we're gonna graph this thing, and hopefully you'll understand after I do this what how we make this work. Okay, so I'm going to do 3 different colors. So we're going to do, for this rule, we'll do it in blue. So if the rule is, if x is less than -2, remember this is what's our x-axis? This is our x-axis. So here's x equals 10, x equals 5, x equals 0, x equals -5, x equals -10. So when x is less than -2, so from here all the way over here, we're going to have kind of one rule. When x is between -2 and 4, we're going to have a different rule. And when x is greater than 4, we're going to have a third rule. Okay, so I'm just going to kind of undo what I drew here. So just wanted to make it clear what we're going to do. So, all right, so this first rule in blue. So if x is less than -2, so it's over here. We're going to, I'll put it back down. When we're in this space over here, we need to graph x plus 4, but we know how to do that. So y equals x plus 4. Let's just go ahead and graph that as if we didn't have any rules, and then we're going to just take away the piece that doesn't fit. So the way that we graph x plus 4, right? 4 is our y-intercept, and our slope is 1. So here we go. So it looks like this. All right? So there's our line. But we only want to have this rule when x is less than -2. So everything that's over here is good, but everything over here we have to take away. So let's do that. Let's just take away everything over here, and let's just include this bit over here. And we also have to look at this little, so everything left of -2 or less than -2 is true. We've got to take away everything to the right. Now, the other thing that we have to do is we have to look and say, is it less than or equal to or less than? So because it's less than -2, what do? We use an open dot. We use an open dot here. So it does not include -2, just things less than -2. Now let's do that for this middle piece. What color should we use? Let's use maybe orange. So now we want everything between -2 and 4. Less than or equal to -2 and 4. So we're going to draw, these lines are not lines in your answer. I'm just putting them in here to just highlight the space that we're going to try and figure next. Okay, so when x is in this range, we have to do, we're going to say f at x is equal to -1/2 x, slope -1/2, plus 4. So now in here, we're going to take, we know how to graph that too. So we go to our y-intercept of 4, and our slope is -1/2, down 1 over 2, down 1 over 2. So we're just going to graph this guy. And we only want the piece that's in between -2 and 4. So we're going to come like this. And because it's less than or equal to, we include -2 and 4. So we're going to draw a solid dot here and a solid dot here. Okay. Now the final thing is we'll draw this one in maybe blue. So this is over here, when x is greater than 4, we say f at x is equal to 5. So that means y equals 5. All right. So if y equals 5, we can draw a little t-chart here just to help us out. Well, when x is 4, y is 5, right? Because f at x, that means y equals 5. So if x is 5, then y is 5. If x is 6, y is 5, because y is always equal to 5. So let's just graph those. 4 comma, whoops, 4 comma 5, 5 comma 5, 6 comma 5, 7. It's always going to be 5. It's going to be this. And why did I know to draw an open circle here at 4? Well, that's because x is greater than 4. It's not greater than or equal to 4 when x is greater than 4. So we need an open circle. So there's our answer. So this is what our piecewise function looks like. Okay. And then our domain, we down here, it's asked for the domain and range. So our domain is x's. So I don't know how your teacher likes to do this, but your domain, oops, why is this not working? Domain is all real. X is an element of reals. I don't know. He may also have you do it like this, negative infinity to positive infinity, something like that. I don't know. Now your range is all the possible y values. Well, it goes down to, here, keeps going down. It could be, y could go all the way down to negative infinity, but it will never be greater than 5. So you're right, because there's no value, the biggest value on this graph in the y direction is 5, right? So there's no value greater than, oops, what's happening? 5. Okay, so the way we write that is negative infinity to 5. Okay, hopefully that made sense. Let's move on. Okay, so this one, let me come back to, well, this you have to graph it. He's trying to help, what he wants you to do is he wants you to understand, what does this do, what does this do, and what does this do? Well, those numbers are, I like, okay, let's see, let's just go down here, let's start here. Well, the domain all reals is good. The range on this graph, you did graph it correctly. So the lowest number here, the range, the y value, the lowest is -2, and it goes up to infinity. So you actually wrote this kind of backwards. It goes from -2 to infinity. So that's the range here. Now, what does -2 do? Let me come back. Let me see if I can show you this. I'm going to show you this and make this really clear using a program called Desmos. You may have used that at St. Simon. I don't know, maybe you used it here, but I'm going to come back and we'll do that. I'll show you that because it makes questions like this super obvious. All right, this one. All right, how do you solve problems? You should know how to solve problems like this. you know, two variables and two equations. So here you want to try and eliminate an x or a y. Here it's really easy to eliminate y by just adding down, and you would get 4x. Let me make this 6 instead. 4x plus 0, y equals 16, x equals 4. And then you go back and you substitute in, and then you'd say 3. And I'm going to substitute into this one. You know, it's 3, because I know that x is 4. 3 times 4 plus 2y equals 10. 12 plus 2y equals 10. 2y equals -2, y equals -1. So that's how you do those ones. But when you get 3, you're going to have to kind of do this twice. And let me show you, or you're going to have to do a couple more iterations before you get to the final answer. Okay. So what the goal is to use two equations to eliminate one variable, and then you need to use two different equations to eliminate the same variable, then solve as you would two equations with two unknowns. Okay, so this is 3 equations, 3 unknowns. All right. So what am I saying here? Okay. So we're going to take the first, so we have to use 2 equations. So we're going to use equations 1 and 2. So I'm going to give you so we're going to look at equations 1 and 2, and we're going to try and eliminate one variable. And I'm going to try and eliminate the x's. Okay, so this is equation 1 and 2. So I'm going to eliminate the x's, and it's simple. I'm going to do that by just adding down. So if I add down, I come up with -23y minus 6z equals -10, right? Now I'm going to use equations 2 and 3 to eliminate the same variable. I have to eliminate the same variable. So -3x minus 18y minus 3z equals -33. Okay. And when I do that, I get -13y plus z equals -32. Now the genius in this is that I have two equations and two unknowns, and now I know how to do that. That's back in 8th grade math, or in regular algebra. So now I'm going to put these two together. -23y minus 6z equals -10, and -13y plus z equals -32. Okay, so what do I got to do here? In this case, I have to multiply the second one by 6, and then I'll be able to eliminate my z's. So I'm going to multiply this one by 6. So 6 times -13 is -78. y plus 6z equals, and 6 times 32 is negative 192. Now I just need to take this one, and I will add down, and okay. So if we add down, we get negative 101 y equals negative 202. Nice, they gave us some easy numbers, so y equals 2. If we divide both sides by negative 101, so y equals 2. If we plug that back into, say, this equation here, we get negative 13y plus z equals negative 32. So negative 13 times 2 plus z equals negative 32. So negative 26 plus z equals negative 32. So z equals negative 6. Now notice we could have plugged it back into this equation or this equation or even this equation, but I chose this equation because it had the smallest numbers, so it is easiest to calculate. Okay, so now to get x, we can go back to any one of our original equations. We can go back to this equation, we can go back to this equation, we can go back to this equation. I'm going to pick the one with the smallest numbers because that's almost always the easiest one to do calculations on. So I'm going to choose this one. So I'm going to say, well, 3x plus 5y plus 4z equals 1. Well, 3x, and we're going to substitute back in. 5 times 2 plus 4 times negative 6 equals 1. So 3x plus 10 minus 24 equals 1. So 3x minus 14 equals 1. 3x equals 15. So x equals 5. So x is 5. Y is 2. Z is negative 6. Okay, again, the keys here, 3 equations, 3 unknowns. You use 2 equations to eliminate a variable, and I chose x because I could see that that was easy to cancel. Then you have to use 2 different equations to also eliminate the same one, x. So I used 2 and 3 because I could see again it was going to be easy to eliminate x by adding down. And then once you've eliminated x, now you end up with 2 equations and 2 unknowns, and we know how to do that. Okay, let's move forward. Solve the following for n in terms of p and r. Okay, so this is just moving stuff around. So let's solve this for p and r. So let's solve first just for r. So if I want to take an equation like this, and kind of I want to get r by itself. So I'm going to my strategy is going to be to move r to this side and then move the 48 back to this side. So I'm going to get the r over there and then get the 48 back over. So let's just see, how do I do that? So if I can multiply both sides by r. So how do I get r off the bottom? I'm going to multiply both sides by r. So I multiply this left side by r and the right side by r. The left side, the r's cancel. I get 6np equals 48r. Now to get r by itself, I just simply divide both sides by 48. 48 cancels, and I get r equals, and 6 cancels with this, gets 8. So np over 8. So that's solving in terms of r. Now I want to solve in terms of p. So now I'm going to look at 6 np over r equals 48. And so I want to get get the 6 out of there. I want to get the P out of there, and I want to get the R out of, sorry. I want to get, because I'm solving for P, I want to get the N and the R out of there. So I get the R out of there just by multiplying both sides by R. So now I have, cancel my R's. So I have 6NP equals 48R, just like I had before. Now I want to get, I'm solving for P, again, I'm solving for P. So I need to get the N off the left side. So I'm going to divide both sides by N. So N's cancel. So now I have 6P equals 48R over N. And now I just need to get rid of the 6. So I'm going to multiply both sides by 1/6. 6 cancels with 6, and I get P equals, and on this side, the 6 cancels with the 48, and I get 8. So I get 8R over N. Right? So it's just this is just a matter of playing with variables, moving them left and right. And I like to do it one step at a time. You can try and do multiple steps in one step, but I just say just be real careful. All right. Let's look at this one. So this one you actually got this right if the question was this. If the question was x plus 8 is less than or equal to 4, or x minus 1 is less than or equal to 5, then it's x is less than or equal to 4, or x is greater than or equal to 6. And then your graph is exactly right. An OR graph takes each graph and then it takes the union. So if I want to graph x is less than this x is less than or equal to 4, negative 4, it's simply this, like you had. And then x is greater than or equal to 6 looks like this, just like you had. And now if I have to, an OR means union, which means either one. So now I draw my graph below. 0, 6, and negative 4. And I look at where either one is true. So I add these together like this. And then you get your answer. Now, if it's an and, it's a different story. So now let's make this an and. Now it's an intersection. So where do these intersect? Where are these the same? Well, there's no, if I look at this piece over here, if I look at this piece here or this piece here, there's no part where they're both solid lines. This has only a solid line over here, and this only has a solid line over here. So my answer is empty set. It's an empty set. There is no place where the whole thing is true for both of them. So let's do a different one where let's just pretend, I want to highlight this. So let's just pretend we had this. Let's say x is greater than or equal to negative 4 and x is less than or equal to 6. So here I would have this graph. X is greater than or equal to negative 4. Here's 0 and here's 6. And here I would have x is less than less than -6. Now we got to look, if you kind of look at this in terms of 3 sections here, where do I have both things being true? And needs both of them to be true. Well, over here in section 1, it's not true, because only this one is true and this one isn't true. So again, I need both of them. So that's not over here, less than -4, no go. How about in between? Well, in between, I got this is true and solid, and this is true. So I can definitely take what's in between. Now look over here. How many things are true? I have, well, this is true, but here it's false. So it's not true over here. So my answer is just this bar in between. So that's intersection. Both are true. Union is just one of them are true. Okay. Write an absolute value inequality for x is less than -4 or greater than 4 is shown on the number line. Well, let's look at this. We have where is x true? Well, it's true at 5. If x is 5, 6, 7, 8, 9, 10, 11, all the way up to infinity. And here it's true it's true -5, -6, -7, -8, -9. So here we have, well, it's basically the absolute value. I mean, what's the absolute value? What's the absolute value of -9? The absolute value of -9 is 9. The absolute value of -8, 8. Absolute value of -7, 7. So we could just say the absolute value of x is greater than 4, right? Because this is x is greater than 4, and this is x is less than -4. But these numbers, the absolute value of all of these numbers is greater than 4, because the absolute value of -5 is 5. Absolute value of -6 is 6. Over here, the absolute value of x is greater than 4 also, because positive numbers are the same as the absolute value of positive numbers. So there we go. Okay, so we've got everything done so far, with the exception of this graphing thing, and I want to show that to you with Desmos. So I'm going to stop this video, and I'm going to pop. Okay, let's look at this last question. So you have this equation, y equals 3 times the absolute value of x minus 5 minus 2. And the question is what happens when, what does the 3 do, what does the 5 do, and what does the minus 2 do? Well, the 3, let's just change the number. Let's just look at this, and let's just pretend that the 3 was a 2. Okay, let's say the 3 is a 1. Okay, well, what do we see it doing? Let's say it's a 6. So the bigger the number, whoops, oh my goodness. The bigger the number, the skinnier it gets. Right, so let's go back to 3. So 3 is, sort of skinny. 1 is fat. 2 is skinnier, and then 3 is skinnier. So 3 makes 3, that number makes it skinny. Okay, so now let's go look at what the 5 does. So let's just change it around. Let's just say that the 5 is a 1. Okay, 2, 3, 4, 5. So the 5 moves it left and right. Now let's look at the 2. Well, if it's a 1, it's up. If it's 3, it's down. If it's 5, it's way down. So that last number just moves it up and down. Now let's look at it. This is kind of a cool way to really see what happens. So I'm going to do this thing called make it a slider. So now remember A is, let's just say I make that a 3. And B is a 5. And then C is a 2. Okay, so now let's just see what happens when I make A big and small. So if I make there, look at that. The bigger, the smaller A is, the fatter it is. Bigger numbers, skinnier. You can do this too. It's Desmos.com. You can just type this stuff in and just watch. So if B is 5, just moves it left and right. And then C being a 2, this just moves it up and down. So that's a cool way to really see what's going on there.